Okay, guys, so jumping right in, we're going to start with the nonlinear inequality part. So guys, make sure those phones are away so you can pay attention to the notes. All right, so nonlinear inequality. X minus 6 times x plus 1 is greater than 0. Jot that down. Now, this isn't a domain question. Like, I didn't give you a function and say, what is the domain? But the process of solving this is very much like what you did with domain. You would just set up this inequality from the domain and then go ahead and solve it. So try to solve this one. See if you can piece your domain knowledge in with this. So you don't have to tell me domain at the end. You just have to solve the inequality. So give it a go. And when you're ready, chat with your neighbors, see if you guys agree. Or if you don't have a neighbor, someone in front or behind you. David, you don't have a neighbor anymore, okay? So. So when I'm saying do it like domain, that means this is a number line problem. Okay. Did we start there, guys, or? We're doing okay? Okay. Good. Talk to each other. All right, guys, I'll go through it. I'm going to test 0. 0 lives between -1 and 6, so that's where I'm testing. 0 minus 6 would be negative. 0 plus 1 would be positive, so that little region is negative. Will this number line alternate? Yes. Yes, good, okay. Getting And then it's all about just answering the question they asked you. They said, when is it greater than 0? Well, that's the positive parts. And what about the -1 and 6? Am I including those or not? See some yes and some no. If it said greater than or equal to, then I'd want to include them. That would be where it equals 0. But since it just says greater than, they're going to be open statements. So your answer to this inequality is -infinity to -1 with a parenthesis, and then parenthesis 6. Infinity. Okay? Yeah. How do I know what? I'm sorry. Oh, sure. So were you fine with how I figured out this part was negative? Okay. If these don't have multiplicity, meaning it wasn't x minus 6 quantity squared, then I know the number line's going to alternate. But if you have even multiplicity, remember when we graphed the polynomials, how it would bounce off the x-axis? With even multiplicity, remember that? That's going to impact your number line too, because when it bounces, it stays, if it was positive, it stays positive. But since there's no multiplicity, it will always alternate. Okay? So find one region and then you know them all. Other questions on that one? Yeah?
Why are we including -1 going to that if it's not greater than 0?
But if I pick a value over here, so it's not that these numbers are greater than 0. Like, let's say...
Oh, wait, hold on. I can have to.
You sure? Okay. All right. Let's try again, guys. Let's do a fraction here. Let's do, actually not a fraction yet. Let's do this one first. X minus 3 quantity squared times x plus 1 times x plus 4 cubed. And we'll say greater than or equal to 0. So try this one for me. You have multiplicity to deal with this time.
I wasn't guessing. I was guessing. Yeah. I wasn't sure how you did it, but I assume you still. Yeah. Yeah.
So you want to take the first of the number line that are common. So let's look at it. I like that and that. So don't want that part. Yeah. One part of it, you're right. The negative 5 minus 3 is this is taking the time for this negative. Oh, yeah. Yeah, but it's still and then you return that. All right, guys, let's go through it. Lots of you out there. Okay, I'm going to test 0. Again, 0 is easy to test. 0 minus 3 squared is positive. 0 plus 1 is positive. 0 plus 4, positive. Cubed is still positive. Are we okay with that whole thing being positive? Right there. Okay. Now, some of you plugged in all the regions because you were like, there's multiplicity. I don't know what to do. I'm just going to plug it in. That's okay. Like, that works. I don't like plugging in that many numbers, so I just want to use the multiplicity to help me. Even multiplicity. We know from polynomials that means like it's going to touch the x-axis and then bounce, right? So whatever it's doing on one side of that 0, it's going to do the same thing on the other side. Okay, that's why even multiplicity matters. Odd multiplicity doesn't really matter with your number line, because if it was negative, it goes to positive. Like, yes, it's an inflection point, but from a number line standpoint, it doesn't really mean anything. So once I've dealt with the even multiplicity, I know my number line will alternate after that. Again, you can plug things in if you're like, I do not feel comfortable with that. Check, that's fine. But make sure you plug things in well. I know we had some troubles with like plugging in -5 and then the exponents and all of that. So just be careful with your signs. And then I want the positive parts because this is greater than or equal to 0. So that's all of this section. And then because it was or equal to, I'm including all of these values, which means I can just say -infinity to -4 with a bracket. And then this is all one piece, just -1 all the way to infinity. Okay. All right, questions on the multiplicity? Are we kind of getting the multiplicity part? You see it a little bit? Okay, we're going to do another one. Okay. X plus 2 cubed times x minus 1 over, actually that's x minus 4, sorry, I can't read my own writing, over x minus 1 squared times x plus 5 squared, and this is all less than or equal to 0. Okay, so that's a significant number line. You have to look at all of those factors together. So you're going to have -5, -2, 1, and 4 on your number line. Give you a minute to try here. Lots of multiplicity to practice with. Check in with your neighbor. Your number line is over. Great. That's what I was thinking.
Oh, since it can't be here, yeah. This
Right?
by 5 or
Don't do it.
2 to 1.
Shall we see the check? Okay. Number line value, like these things can't be positive, but it's not just numbers. So oh, okay. It's the outcome. Okay. Like, giving it a second to finish. All right, I'm going to test 0 to start with. 0 plus 2 is positive, cubed is still positive. 0 minus 4 would be negative. 0 minus 1 is negative, but squared would be positive. 0 plus 5, positive, squared, still positive. So overall, that little region is negative. Are we okay there? Okay. I see a couple of zeros with even multiplicity, right? Here and here. So that's this guy and this guy. That means around those zeros, the number line isn't going to alternate. It's going to do the same thing on both sides. So it was negative on one side of 1. It's going to be negative on the other side. Okay? But then it'll alternate after that. So the other side of 4 will be positive. Okay? Around negative 2, it should alternate. So it was negative on one side, it'll be positive over here. But then negative 5, that's got even multiplicity, same thing on both sides, so this is a plus. A little better with the multiplicity? Catching on? Okay. Now, I have been asking you over and over for greater than or equal to 0. That's not what I asked you for this time, okay? I asked you for less than or equal to 0. So I want the negative parts. And now it says less than or equal to. So right away you might have gone, oh, okay. I want to just say from negative 2 to 4. But then we also have to think about the fact that this is a fraction. And look at that denominator of the fraction. I know right away it can't be the negative, oh, sorry, it's a 1. Make sure I circle the right thing here. And it's not really mattering right now, but it also can't be negative 5. But the negative 2 and the 4, those are good. Does that make sense? Like that's back to what you know about domain, that the fraction, the denominator cannot be 0. Okay, so your answer is negative 2 to 1, parenthesis, union, 1 to 4 with a bracket. There's a lot of details in there, okay?
So do you just want to give why the 1 is in a bracket?
Yeah, like why that's in parentheses.
Yeah.
So if I include the 1, and I plug a 1 in right here, what happens? The what? What do you mean by cancel? 0. It's 0, okay. 0 times whatever this is also 0. So now the denominator of my fraction is 0. Is that okay? It is not. We can't divide by 0, so I can't include the 1. I also can't include the negative 5, but that didn't come into play. Yeah? And you see why the negative 2 and 4 are fine? Because they're in the numerator? Okay. All right, other questions on that one? All right, we're going to do one more nonlinear inequality. Let's do x minus 3 over x plus 4 is greater than 3. What's different about this one? Yeah, it's greater than 3. Okay, we can't do it when there's a 3 over there. We have to make it a 0 on that side. So how do I do that? Subtract 3. Now, please, please, please do your subtracting right. I don't just like smush a minus 3 into the numerator. It's minus 3 over here. And how can I combine those? Like, what do I have to do? Yeah, because right now it's like 3 over 1, and so I would need a common denominator of x plus 4. Okay. So I've got x minus 3, and then if I distribute, this would be minus 3x minus 12. And that's all over x plus 4. This is greater than 0. So really, I've got negative 2x minus 15 over x plus 4 is greater than 0. That's what you actually have to do the number line for now. Okay? So I'll let you try from there.
Why did we multiply this like distributed instead of subtracted?
So, okay, we could do it. Let me just write it over here to the side. If you want to just leave it as subtracting, you see it? It's the same. Yeah, no problem. There he is. Check in with each other. Oh, okay.
I did it, but I don't know.
Yeah.
Oh, I keep forgetting it's not.
So,
I don't know if it's right, but at least one of them, I said.
yeah, that's really always. Oh, there we go. Draw the number. And so that kind of just threw off. All right, guys, let's look at this one. So guys, picking out the points on your number line, I think that's actually the hardest part on this one. Remember, you're just setting the numerator and denominator equal to 0. So denominator's easy, that's -4. The numerator, that's -15/2, which is like -7.5. So that's got to come first, and then the -4. So when you're plugging in 0, that's really over here. Okay, and you'd have a negative numerator, a positive denominator, so overall negative. There's no multiplicity, so they will alternate. Okay, so then your answer just greater than 0, that's just parentheses -15/2. Or if you said -7.5, that's completely fine, to -4. Okay, question? All right, that's nonlinear inequalities. Now we get to do partial fraction decomposition. So you guys are excited. All right. Okay, so we're just going to jump in. I'm starting over with number 1. We've got x minus 1 over 3x minus 5 times x minus 3. So you guys have done like adding and subtracting fractions where you have to find a common denominator. This is the reverse of that. We have like these fractions that have been combined. You're going to work backwards to what the two fractions originally were that were added together to create this fraction. Okay? It's something that is beneficial when you get into BC Calc, but right now you just have to learn the like basic building block of it. So there's a lot this year that is kind of like learning the final building block of something that then in calculus you get to put it all together. So, you know, we'll just learn our building blocks right now. All right, so the way this works, this is what it looks like. You'd be given this fraction. I see two factors in my denominator. Sorry, shut the door. The hammering this morning is quite. Okay, so when you have two factors like that, we're going to put an A, capital A, over the first factor, the 3x minus 5, plus B over the x minus 3. If you'd had a third factor, then you'd have plus C over that factor, okay? You're just going to work your way through. All right. We're trying to solve for this A and this B. So the first thing I'm going to do is multiply the entire thing here by 3x minus 5 and x minus 3. Why do you think I'm picking those two things? Exactly. To get rid of the denominators, we don't really want these huge fractions that we're dealing with, okay? All right. So on the left, everything will cancel out, and I'll just have x minus 1. Then for the A fraction, do you guys see how the 3x minus 5 is what will cancel, but I'll have A times x minus 3? Okay. And then the B fraction, the x minus 3 cancels, and I've got 3x minus 5. Okay. So far, so good? All right, there's just a lot of algebra at the beginning of this. Okay, next I'm going to distribute my A. So x minus 1, this would be equals ax minus 3a. And then distribute the B, so plus 3bx minus 5b. Okay, I'm just going to move some things around on the right side. So left side is still just x minus 1. Over here, I'm going to put the ax first, and then the plus 3bx next. I'm going to put the two things with x's next to each other. And then I've got minus 3a minus 5b. Literally just moving things around. Okay, x minus 1 still on the left. So those first two terms, let me write this and see if it makes sense to you. A plus 3b times x. I factored out an x, but I'm just writing the x after the parentheses instead of from the parentheses, not slimline. Do you see it, though, that that's all I've done is factoring? Okay. And then I still have this minus 3a minus 5b happening here. Okay. The reason I did the x after the parentheses, the a plus 3b, that whole quantity, that's the coefficient on x. Okay, what is the coefficient on x on this side? 1. So I can set 1 equal to a plus 3b, because those coefficients have to be equal. And then I can also set up my constant. So on the left side, do you guys see how -1 is the constant? So -1 has to equal my constants over here, which are the -3a minus 5b. Let me stop there for a second and make sure you guys are good. Just let that soak in for a moment. Do you guys see what we've done so far? Okay, now we're down to solving a system of equations. Do you guys remember solving systems? Yeah, you had like elimination, substitution, or graphing, which you never pick graphing. That's fine. So, you could do whichever way you wanted here. I'm going to go ahead and do elimination, I think. I'm going to take this one times 3, and then I'll just write that down here. So I have 3 equals 3a plus 9b. And then I can just add those together. So that eliminates the a. I can have 2 equals 4b, which means b equals 1. You with me on that elimination step? Okay, so that's one little piece. Now that I know B, how do I go about finding A? Yeah, plug in B, and it doesn't matter which one you plug it into. I'm going to go to this first one just because I have room under it. So I'm going to write 1 equals A plus 3 times 1/2. So I'm really subtracting 3/2 from both sides then. So what is A going to equal? Yeah, -1/2. Good. Okay. So I've got the A and B. Remember way up at the top how I wrote A over 3x minus 5 and B over x minus 3? That is what you're essentially going to do now. That's how you write your answer. So I'm going to write -1/2 over 3x minus 5. I think that's what I had A matched with. Plus 1/2 over x minus 3. Is that very pretty, though, with a fraction in a fraction? Like, do we like that? No, I would not want you to leave it that way, okay? So what's really happening? It's -1 over 2 times 3x minus 5 plus 1 over 2 times x minus 3. Those are the same thing. Okay, so that is your final answer. Questions on that first one? Okay, so with these, if you took the time to actually add them together, like find your common denominator and go through all of that, you would get back to this x minus 1 over 3x minus 5 times x minus 3. Again, we're not going to do that, but that's where you would end. Questions before we try another one? Yeah.
So, why would you pull out the negative in the -3a minus 5b? The way you put out the I is for the
Sure. So like here, doing like -1 times 3a plus 5b.
Yeah.
So the whole thing, the A's and B's are just numbers. Like, they're variables right now, but they're not X's. They're just representing some constant. So even if you factor it out, you would still be setting that entire thing equal to -1. So if you wanted to do it like 5b. You could certainly divide by the negative right away, so you have a positive 1 equals 3a plus 5b, and work from there. But it's going to be the same thing in the end. Yeah.
Okay.
Yep. It's this first one, we did this over here because that a plus 3b together, that number is the coefficient on x. Okay? All right. Other questions? Okay. We're going to try another one, and we're going to do this one in a slightly different way. All right, we've got 1 over x minus 3 times x plus 1 squared. Okay, how many factors do you see? 3. Okay, so, is that x plus 1 twice, right? So the way you write this, a over the x minus 3, b over just a single x plus 1, and then c over x plus 1 quantity squared. I know you don't like it split up like that. If it was x plus 1 to the 4th, you'd have x plus 1, x plus 1 squared, x plus 1 cubed, x plus 1 to the 4th. Like, you just have to build up to what the highest exponent is. I'm not going to give you one that's to the 4th. You're going to see squared, and that'll be as high as you see. Okay? All right, so first step, remember, we have to multiply by something. What am I going to multiply by this time? Good, yeah. That denominator I have in purple, that's what you want to go with. Question over there, sorry.
I'm kind of confused as to why we added the c divided by x plus 1.
So, how many factors do you actually see here? Okay, so I need an a, a b, and a c. And I can't just do x plus 1 and another x plus 1, because that wouldn't actually give me x plus 1 squared as a common denominator. It would only be x plus 1. So this one's easy, like we see that. Anytime you have some quantity to an exponent, you're going to have the build-up to whatever that biggest exponent is. Okay? Because we can't leave this out, because then we don't really have 3 terms now, right? And we can't do just 2 of this single one, because that doesn't get me to this common denominator, okay? So we've got to have all 3 of those things there. Okay, so I'm going to multiply. The left side, I'll just have 1. What is a going to be multiplied by?
X plus 1 squared.
Good, x plus 1 squared. Okay, what about b? Yeah, it's going to have an x minus 3 and an x plus 1. Good. And what about c? Good. Okay, don't do anything yet after this. Are we okay up to that point? Okay. In the last problem, then, I would have multiplied this all out and combined things. But then you'd have a system with 3 different variables. You'd have an a, a b, and a c you're solving for, and that's not super fun to do. Okay, so there's another way we can go about doing this. We can substitute some values into this to eliminate the a's and b's and c's. So let me just walk you through the first one, and then I think you'll catch on. So I'm going to let x equal -1. And this 3 times. Why do you think I picked -1? It's going to get rid of the a. Is it going to get rid of anything else? Yeah, it's going to get rid of the b also, because anywhere, if x is -1, anywhere there's an x plus 1, that becomes 0 times all the other stuff, right? Okay. So the left side of my equation is just a 1. Now, guys, if there had been x's in this numerator, you know, and I have x's over here, you'd have to plug that -1 in over there. We just don't have any x's on that side this time. And then -1 in here, this is all gone. -1 here, this is all gone. So all I have left is the c. So 1 equals c times -1 minus 3. So 1 equals -4c. So -1/4 is c. There's one of my answers. Are you with me on that first one? Okay, what do you think I'm going to let x equal next? 3, good. Okay, so I still have a 1 on the left. What does x equaling 3 get rid of for me? A, B, or C? Which ones? B and C are both gone, so I just have A times 3 plus 1 quantity squared. So that'd be 4 squared, so 1 equals 16A. So I have 1/16 for the A. Okay, well now I don't have anything else nice to plug in, right? I used up all my factors. So I still need to find B. I can still plug in really any other x value that I want. What is a super easy x value to plug in? 0, yes. So if that's an option, like if you haven't already used it as one of your factors, let x equal 0. Okay, so the left side is 1. Now, x equaling 0 does not actually eliminate any of the a's or b's or c's. But do I know what a and c are? Yeah, so I can substitute those in as well so that the only unknown in this whole thing is b. So I'm going to have 1 equals 1/16. And then times 0 plus 1, I'm going to just say 1 squared. Plus b times -3 times 1. Plus, minus 1/4 times -3. Are we okay with the plug-in in there? That doesn't look like a 16, but it is. Okay, so let's simplify that a little bit. 1 equals, well, 1/16 times 1, that's still 1/16. And then this would be minus 3b plus 3/4. You with me? Fun with fractions on a Friday, right? Good alliteration for us. All right. What is 1/16 plus 3/4? 13/16, yes. Okay, I was just going through common denominator there. 4 times 4 over 4 is how we get there. Then I have to subtract 3/16. So what is 1 minus 3/16? I said it, didn't I? Sorry. Never mind. Okay, 3/16, and that equals -3b. Yes, -1/16 is your b value. Whew. They aren't all that messy, okay? But that one was. So we have A, B, and C. Now we have to write the final fraction, okay? Whew. All right, so A was 1/16, so I'm going to write 1 over 16 times x minus 3 over 16 times x minus 3. B is negative 1/16, so I'm going to write minus 1 over 16 times, I think that one was just x plus 1, right? And then C is negative 1/4, so minus 1 over 4 times x plus 1 squared. Okay, how we doing?
That's the answer.
That's the answer. It's so nice, isn't it?
How do you know what values to plug in for x?
Good question. So the first two, we had negative 1 and we had 3. Do you see why I picked negative 1 and 3? Yeah, because you want to eliminate things. This one, you could have been like, hey, I really like the number 35. Sure, you'd still get there. It'd be really ugly. But you can pick whatever number you want for x. You just have to substitute it in anywhere there's an x. So we pick 0 because 0 is easy.
But would you get the same answer if you plugged in any value?
So the first two, like, if I had started with the 0, like, I'm going to start by plugging in 0. That's fine, except you'd still have an A, a B, and a C. And you have 3 variables. How are you going to solve that equation? So we picked these two because each one of those will eliminate 2 of your variables. By the time you get to this third one, you already know the other 2 variables, so you can plug all of that stuff in. Does that make sense? Yeah. Should we try another one, guys? See if we've got this. All right, let me give you another one. What? Just a minute. You sure? Okay. Let me find you a good one. Sorry. Yeah, go ahead. All right, we'll start with this one. Negative 5x minus 41 over x squared plus x minus 12. You're going to have to factor your denominator. And now, guys, it's only going to have an A and a B, just like our first one did. So you can pick which method you want to use. If you liked the first one where you solved your system, go for it. If you're like, no, I'd rather just use this substituting way every time, you can do that as well. Okay? Sorry, let me go back to it. So I'll give you a minute to try that one. And guys, of course, you can work together if you want to. If you're stuck, check. How we doing, guys? Did we get to an answer? Okay, so you're trying to do it. Yeah. Now, let's
Yeah, so I didn't.
Yeah.
Well,
I didn't drop it. I just put it there. And then I thought,
Yeah, we can't stop.
so.
Okay.
This applies to yeah.
Okay, guys, I'm going to go ahead and go through this one. Okay, from this step, guys, you pick. You can use the first method or the second method. It doesn't matter. I'm going to do the second one, I think. So I'll do let x equal 3. And then my other one. So when x is 3, I would have negative 15 minus 41. B would be left. So let's see if I can add right. 51, 56, right? So I've got negative 8 for B. Everybody okay there? And we'll do negative 4, so that'd be 20 minus 40. Okay. So I got 3 for A. Now guys, you might have had your A and B in a different order than I did. I had A over the x plus 4, so as long as you ended up with 3 over x plus 4 and the negative 8 over, what was it, x minus 3? Thanks. Okay. All right, question questions, yeah.
So I just want to make sure when you have, you can do it either way when you have two, but when you have one or two, you have to do it separate.
Yeah, I mean, you could do it the first way, but you don't want to, okay? It's very painful. All right, questions? Okay, do you want to do another one, or do you want time to start on your math space? Math space it is, okay. So there's homework assigned, and I'm going to go ahead right now and assign second attempt on 2-3 for you so that you've got that as well.